On question 6, I am going to do videos for the separate parts, just to emphasize the similarities, but more importantly, the differences of what you can be asked in these different problems. So it asks for a pH of a solution that has HCl, and hopefully that pops off the page to you as a strong acid, and then HCHO2. So that is a weak acid. We don't need to know its exact name or strength or any of that, but we would have to be given its Ka. One thing that's kind of important to remember is that Ks are normally really small for weak acids. So this is in the realm of one of the bigger Ka values. So even though this is weak, it is one of the stronger weak acids. So when we plug in our math here, we have our x squared over our molarity is equal to Ka. And that tells me that when that weak acid ionizes, I get 0.004 molar hydrogen ion. So that's from solving our Rice table, our equilibrium, and our K value. But because HCl is strong, 100% of that HCl ionizes into H. So it comes out as 0.1 molar. So this goes back to problems, I think, number 2, where we were still introducing or refreshing ourselves on pH, pOH, all of that, and doing it with strong acids and bases. We want them to be strong. So the negative log of just the concentration of a strong acid or strong base gives us our pH or our pOH. So if I were to sum these two together, we see that in terms of sig figs, really there is no difference by adding in our weak acid. So that one's only known to 2 decimal places. When we add in the 0.004, that doesn't increase it or round it up. You can do both parts, but what we see here is the negative log of this is 0.98. The negative log of that is 0.1, and those are so close to one another that we're not seeing a big change in pH accounted for by that weak acid. The other thing that I didn't do in the work here was showing that right here, the fact that there's some hydrogen ion from the HCl would actually be a common ion effect and would shift our equilibrium a little bit. So even though we kind of treated these as if they're 2 separate solutions, by being in the beaker or the container together, the HCl would actually make this ionize even less. So if this fully ionized in water, the amount of hydrogen ion it produced would be tiny. When it's with a strong acid, it would produce even less. So this is to kind of show that when we have a strong and a weak, we only need to account for the strong in terms of pH and hydrogen ion concentration with the sig figs. But what would happen is we would think about maybe a question like this in terms of multiple choice and concepts. What if we had this just in solution, what would we have high concentrations of and low concentrations of? Well, we'd have a lot of hydrogen ion. We'd have a lot of chloride ion. We'd have very little of this anion here. It looks like the formate anion. Obviously, the hydrogen ion we'd have from both. We'd have a whole lot of the formic acid, but we could kind of rank those things because this does ionize a little, so it's not 100% together. But we have way less of the formate ion than we would have the chloride ion. The chloride ion would be really high, but we would technically have a tiny bit more hydrogen ion than we would chloride ion because we do get hydrogen ion from each of those. So just thinking about that conceptually, what do we have a lot of or a little of? What totally ionizes versus partially ionizes lets us take it further from just a math problem to understanding what that means in solution.